So in the second part, we're going to focus on creating the controller, so we will actually be able to move around. As you can see, I've already dropped a plane with just has a grid. Well, it just has a texture. Okay, it doesn't matter. And before we actually go and write any scripts, we're going to go on the edit and go into project settings, input, and we're also going to make the controller both for the keyboard and, well, you know, an actual controller. And I have an Xbox 360 controller, so this is what I'm going to be using. Okay, it's from the wiki for Unity 3D. So I'm going to leave that on the left side. If you have a different controller, just know that things are going to, you'll have to set up things a little bit differently. Now, we have some that we can work already. You can see we have the horizontal, vertical, and we also have it for the controller. These are actually for the left axis. Now we need to make the right axis. So I'm going to go on the mouse X and I'm going to go duplicate array element. I'm going to just call this right axis and I'm going to call this X, and the axis type, I actually want the fourth axis from all the joysticks. Okay, we should probably set up the same values for this, so that will be at 0.19, sensitivity at 1. It's basically just the same ones, and the type we actually want the joystick axis, and this will be the right stick going up and down. On the mouse Y, I'm going to duplicate the array and I'm going to call this right axis Y. Let's go with 0.19, the same way as the other one. Sensitivity will be 1. We change, let's change this also. And we want joystick axis, and I think this will probably be the 5th. Yeah, it's the 5th. Oops, not the 7th. 5th axis. Okay, we now have both our axes into the controller working. We're going to change later the fire 1, 2, 3 and stuff like that. We won't need them. We're actually going to create new stuff. Now, I've created a new script, just an empty script, input handler, which is going to be what we are using to basically control all our inputs. We're going to create afterwards a state manager, which is going to be updating stuff from the input handler, well, depending on the input, of course. And it's going to be really useful because we're going to be storing everything that we might need to access. Before we do that though, let's go into our Boxman, and for right now, well, we don't need anymore the helper, remove him, and what we actually want is to not use on the same game object we have our animator. We want this to be a child object for our controller. So I'm going to create a new empty game object, just make sure they are on the same position, and I'm going to call this controller. I'm going to drop the Boxman underneath it for now, and on this one let's go with a capsule collider for right now, but in the future we're going to change this. Let's go with 1, let's go with height 2, but as I said, in the future we're going to change a lot of this stuff. Let's add a rigid body, and we can change the constraints from here, okay, so that we do not tumble around, and right now this will do. Drop the input handler and let's open it up. We have horizontal float, and let's just start with 0, and we also have our vertical, or maybe it's better if we keep the vertical on top. On start, we're not going to do anything, at least for now, until we have a state manager. So on fixed update, the vertical will be input get axis. It's probably with a capital vertical, or oops, not ZZ, or input get axis. Actually, yeah, this is a mistake. They have the same name on our input manager. Project settings, input, they have the same name as you can see, horizontal and vertical with the keyboard, so there's no need to have it differently. So we can just keep it like that. We need the right axis though to have different names, because we're going to use the right axis for looking around with a mouse, and you need to have different forces, or well, different speeds when you are rotating, because of the values that you get from either the mouse or the actual joystick. So with this way we can, if we are using the controller, we're going to be applying a different speed on our camera rather than if we are using the mouse. Back to this now. We have our horizontal, input, get axis, horizontal. Okay, very simple, and we basically get our input. I'm going to make this also into, I'm going to encapsulate all my inputs in here though, and I'm going to take this and drop it in here. Let's go create the state manager now. Because I want to have my input handler pretty clean. And I'm going to create a namespace. We don't want any of this. We're going to be handling the updates all from the input handler. So the first thing we're going to do is make a public float horizontal. Make on top of that a public float vertical. We want our animator. Actually, I'm going to make it public. We want our rigid body. Let's go with rigid. And what else should we need? I think these two will do for now. Public void init, basically the start, and we're going to be getting the components from in here. Actually, the animator, it's not on the same game object. So what we're going to do, I'm going to create a game object and I'm going to say active model, because you'll be able, on the final one, you'll be able to use your own models and change the models. So we need to make sure that we actually have an active model. And the animator now is going to be on the active model object and get component animator. For right now, what we can also do, say if the active model is null, then we probably forgot to assign it. So what we can do is do get component in children. Now this is not entirely safe, and that is because we might not actually have an active model, or we might not actually have a game object underneath a controller. And we can say if animator is null after that, then throw a debug log or whatever. No model found. Otherwise, the active model should be the same one as the animator. Animator.gameObject. And over here we can say if anim equals null, oops, then don't do anything. If it's null, then go find the animator. So we have our animator. Let's do the rigid body, or better, maybe it's probably best if we encapsulate this. Set up animator. And since we're here, Apply root motion, we want to start with false. Setup animator. Rigid body will be in our same game object, and we have our rigid body also. And then we're going to use public void tick and over here. Now we're actually going to start optimizing from now so that we don't care what we are doing later. So I'm going to create an actual delta over here, and every time I want to access time.delta time, instead of getting it manually, the usual way, I'm going to be getting it from the state manager, because it's going to have everything I want to use. We can actually hide these two because we don't need them in the inspector. Okay, so for the tick to happen, let's force it so that we actually need to be passing a delta, so just so that we do not forget it in the future. Okay, very simple. We actually can hide this also, since we don't necessarily need it, and we can keep the inputs just so that we know that we actually have some input. Now, on our input handler, let's create the state manager. Let's call it states, and states will be, of course, get component, state manager, and initialize it. You have your input, and let's make this also over here, update states. So on our states, on the delta will be time dot delta time, and then states dot tick. Actually, instead of doing it like this, we're just going to delete that, take this, and put it over here. So this is going to update the actual state manager depending on what we're passing. So over here we can simply do states horizontal will be our horizontal, and states vertical will be our vertical. Now we also want to have the camera, because our movement is going to be camera based, so we need to create the actual camera holder. So I'm going to create, I want to create an empty game object. Oops, yeah, I want to create an empty game object underneath my player so it has the same position, and I'm going to unparent it. I'm going to call this camera holder. I'm dropping the main camera underneath the camera holder. I'm going to reset it. I'm going to bring it back, and I'm actually going to create another empty game object. I'm going to parent the camera underneath that, and I'm going to call this pivot, pivot. So the pivot will work as rotating the camera up and down, while the camera holder will rotate the camera left and right. Let's take the pivot and make it higher up. Let's go a little bit further up, and maybe the camera can go a little bit further back. Let's create the controller script over here. Let's call this camera manager. Let's create the namespace. Since we're going to be accessing the camera manager a lot, and there's probably going to be only one camera inside our scene, well, at least one camera that we're going to be focused on, then we can make this into a singleton. Now, if you are afraid that you might have more than one camera, you can just do a check if singleton is not null. then destroy the game object. For whatever reason, it doesn't show right now, but doesn't matter. We're just going to do a singleton equals this, and we have our camera now. Oops, yeah, no, this is correct. We actually don't want to have the camera to update by itself. You'll see why. And maybe we want it to update to, yeah, let's just go with initialization manually. It doesn't matter. And we can also pass the delta in this one. Okay. So on the tick, we actually want to have our two, our values. So this one is going to be, for some reason, yeah, it's just giving me problems. He hasn't found this one, so I'm going to close the, I'm closing Visual Studio and opening it again. Okay, now it works. We can see that we can actually have mono behavior reference. That's why I couldn't use destroy previously, but yeah, it doesn't matter. We don't need it right now. So we have our float horizontal, and this one is going to be input get axis, and of course it's going to be called mouse X. We want also our vertical get axis mouse Y. Oops. Now we actually want to separate the inputs into controller and mouse, so I'm going to just use get axis, right axis X, and then C V, right axis with Y. The reason for this is because if there is controller input, okay, there's no chance that you're going to be using both the controller and the mouse at once to move the camera. So whenever there is controller input, we're going to basically override the inputs we get from the mouse. To do that, we're simply going to check if there is if there is any input over there on that controller. So I simply check if the values are 0, if not they are 0 or not, and then we simply do H, and then V equals, we're going to use a few values. So we have our mouse speed, and we also want our controller speed, but let's set up some value at least. The controller usually needs a little bit more, so I'm going to just set it as 7, and we also want a target to be able to follow a target. Public transform target, and although we can initialize with just a target with an empty target, let's just note at this point. Okay, so we actually have a target. We have our tick, and let's have our, maybe call this follow target. This is going to be pretty simple. Oops. We have our vector 3. Our target position will basically be a lerp between our own transform position with the target's position, and we can pass the time dot delta time, but since we're going to be passing it from here, let's call this in here and put the D in here and in here. So our transform dot position will be our own target position, or the target position, the new target position we want. So we have this over here, follow target. We are passing the D. Yeah, I think maybe we should probably separate this a little bit more. So we're going to call this public float follow speed. Let's go with 9. And we can have a speed which was going to be D multiplied by follow speed, and just pass this as over here, the speed in here. Alright, very, very simple. Before we actually tackle the rotations though, we need to have the pivot, and for good measure we probably need to have our camera transfer also. So on initialize, well, let's go with camera transfer. Since we know that one what's going to be, it will always be camera main.transform. So the pivot will be the parent of the camera transfer. Okay, so we have both of these in here. We have our inputs, follow target, and now we only need to fix the rotations. So handle rotations, our delta, and vertical and horizontal. Okay, can't get any simpler than this. And actually we're going to also pass the target speed as a float. So in here we'll start with target speed will be the mouse speed, and if there is controller movement, target speed is going to be the controller speed. And handle rotations, we need to pass our delta, our vertical, our horizontal, and the target speed. Now we need to have also a little bit of smoothing, so we're going to basically create a few more stuff. Let me check my notes, because we need to apply slight well, for example, we need turn smoothing, which we're going to start with 0.1. We also need to know our minimum angles and maximum angle, so something like 35 will probably be enough, but of course we can always change them. Let's write this correctly. Oops, 35, come on, 35. And let's go back into handle rotations. So if we actually have some turn smoothing, we are applying it, then we need to use the smooth, we actually need a few more variables. Float, we need some place to store the smooth X and some place to store the smooth Y. Okay, just in case you actually have a value into turn smoothing. So turn smoothing, then you're going to have your smooth X. Come on, smooth X is going to be, well, mathf, smooth dump, smooth X, dx. Well, actually we don't have an X, we have a V, and we actually need to also create a smooth velocity. And let's see, this will be, let me think. Oh no, we don't. We actually, this is going to, it's going to be what returns you the smooth velocity. So for right now you can just have a smooth X velocity. Okay, we've seen these scripts actually before, but you know, in the spirit of making it all from scratch again, we have to see them again. So if you want to just jump ahead a little bit, you can. We have our smooth X velocity. Okay, and then we can pass our turn smoothing. Let's copy paste this for the Y. We want this to be capital, smooth X, Y, and this should be H actually. And this, yeah, this should have stayed V. 1 V, and this one smooth Y velocity. Otherwise, we are only taking raw input. So smooth X is going to be whatever you have on the H. Smooth Y is going to be whatever you have on your V. Then let's just add a new boolean for a lock-on, because our camera is going to behave very differently if you are on lock-on mode. But for right now, we're just going to do if lock-on and leave it like at that. Okay, we don't want to mess with anything at this point with the lock-on. And we also want, let's make it public so that we can monitor it, our look angle, and we also want our tilt angle. Again, these don't have any reason to be public. I'm just making them so that we can see them. You know, you can serialize them or whatever. It doesn't matter. So, look angle will basically be your smooth X position multiplied by your speed, or basically how fast you are turning. So that will be our target speed. And then the transform for this, the rotation is going to be quaternion.Euler 0, look angle, and then 0 again. So this will rotate your camera on the y-axis. On the y, you know, left and right, and up and down we'll handle it by the pivot. And the tilt angle is going to be minus the smooth y, because we want to go opposite, multiplied by our target speed, and then to make the tilt angle, we have to clamp it between our angle, between our minimal angle and our maximal angle. Come on, maximal angle, and then simply on our pivot dot local rotation we can do quaternion dot Euler, and we only want the x-axis, so this is going to be tilt angle 0, 0. And here we have our camera. Okay, we need to initialize this, and we also need to be calling the tick. So on our input handler, we're going to create the camera manager, a reference at least to the camera manager. We're going to call this camera manager. We're going to also initialize it, camera manager, and we can just take it from camera manager from the singleton. We need to initialize it, of course, camera manager dot init, and we're going to make it to this transfer. And on update, or the actual update, we don't want to mess with the fixed update. It doesn't matter, because the camera, all it's going to do is probably just going to follow us. So we can try with update, and if we have any more problems with it, then we can just revert back to the fixed update. So camera manager, tick, and we probably should just store this again somewhere else, float delta, call the footprint for the delta time. Okay, we're going to call this again in the update because the fixed update is going to run a few more times. Although actually this might be, yeah, if you want to be more picky about it, you can do this in fixed delta time. Oops. Fixed delta time, and this one again overwrite it with a proper delta. But you're not going to see any difference, to be honest, so it doesn't matter. Okay, so dropping this in here, camera holder, camera manager. Let's set up our controller a little bit also. So we need also the state manager. We have almost everything we need. Let's put it in here, let's hit play. And you can see that I can actually rotate with my mouse. Let's go to the controller and you can see that I can actually rotate with the controller. Now the controller is a little bit too fast and we can go into the camera holder, change the controller speed, maybe something like 5 should probably do. Yeah, something like 5 is probably better. Okay, very, very simple. Now let's get this guy moving. Set this to 5, save. Let's go into our scripts, and on our state manager I actually want to go and grab my or store my camera, or actually I'm going to be passing the moving direction that I want through the input handler. So I'm just going to set this up as public div move direction. Okay, we're going to handle everything in the input handler. On fixed update we have our input, so that means we need to create, based on the input we need to create everything else we're going to need. Let's just drop it inside the update stage. So we have our camera handle. We actually need to make this public, or at least let's make them public as well, just in case we might need them later. But I think for right now, or for the most part, we might not even need them. So what we're going to do on our input handler update stage, we need to create a few vectors. The v vector is going to be our stage.vertical, multiplied by our camera manager on transfer, which is the camera manager in this case, or the transfer for the camera manager is going to be our Y pivot, so rotating left and right. So if we do forward, that means we have the orientation of where the camera is looking. We don't care about the up and down. Okay, we only want to care about on a 2D dimension. And the horizontal is going to be, let's just do it like this. And the horizontal, as I said, is going to be horizontal multiplied by camera manager transfer dot right. So the move direction it's going to be your vertical plus horizontal multiplied first normalized. Okay, that's going to be your target moving direction. So if you apply this to a rigid body, you're going to be moving based on your camera angle. Now we actually want to use one more thing. On the state manager we're going to call this public float move amount. Let's go with that. Now input handler, we can actually just take this, and to be honest there's no need to create a new move direction. So the move amount for this is going to be our horizontal, well, a clamped horizontal basically. States.move amount horizontal plus vertical. Actually, it's going to be the, yeah, let's write it a little bit clearer. Float, let's go with them, will be, we want the mathf.abs of horizontal added on the mathf.abs of your vertical. So basically this will work as a raw axis that is going to tell you that there is movement into you from your controller or something, and we're going to multiply that on our animations, or well, before we add it on the animations. So if we are only moving slowly, we're going to be playing the walk animations, and you know, it's not going to fly off and play a running animation directly. And we actually need to also clamp this, or maybe yet let's just go directly into the move amount. So let's do a mathf.clamp dm. Maybe we don't need the absolute, oh yeah, we need the absolute values, and the minimum of course is going to be 0, so we can just do a mathf.clamp01 with the m. Okay, this only tells us that there is movement, and that amount of movement there is. So if you are pressing diagonally, you're not going to fly off. We only want this to be multiplied on your, well, you know, on the controller. So we cannot use 2, because that will mean that we basically want to move on double the speed, which is not something we actually want to do. So how that translates into movement inside the state manager, we're going to call this fixed tick, because we're calling it in the fixed update. So let's go, oh, we're not actually, yeah, here's where we're calling it fixed update. And let's also get this one over here, because we're probably going to forget it. And for a state manager, let's say we can basically go with our usual add force. We'll see, but we're going to see this in a bit. Or we can multiply the velocity instead. Yeah, I think maybe velocity is going to work a little bit better in our case. So we have our move direction. That means if we get a rigid body, okay, and our velocity, let's just hard code it into move direction right now. Now the reason why this works is actually because we are updating these values before we call the update of the state manager. Okay, get input, update states, we're updating all of this, and finally we are calling the fixed tick. Maybe we should make it a little bit more clear. We are calling it in here. Okay, so let's see what this is going to do. It's probably either going to fly off or it's going to go too slow. Yeah, it's going too slow, but you can see that we actually have movement, and I'm pressing forward. Okay, and I'm going towards where the camera is looking. Same with the controller. Okay, it works for the controller as well. Let's go and write a few more stuff before we finish. And let's make it to have a proper velocity, at least. So we have our move direction. Let's add a speed. Maybe we should add regions over here. Let me think which one it was. Yeah, let's go with headers. inputs. We probably don't need the rest of the stuff, but over here let's set this up as, let's call it them stats, and this will be on the top, to be honest. Let's just leave it at init. Public float, move speed. Let's create another one. Let's call this run speed. Now move speed counts also as the jogging speed. Okay, so it's not only the walking speed, it's basically the maximum of your jogging speed. The running speed is when you are actually sprinting. So let's go with maybe 2 over here, and maybe running speed might be 3.5. I don't know, maybe it's my idea, but when you are having you know, speeds that are actually based off the multiplication, so if you have 2 then your running speed is 4, it's usually you can tell, and it's not really that nice. I don't know, maybe it's just me, but yeah, I don't actually like this to be 2 and 4, so that it's not that much predictable. I don't know, maybe it's just me. So move direction multiplied by our move speed, for now at least. Okay, we don't really going to use that. We are now moving much faster. If we go with this to 8, and oh yeah, we want 8 on the state manager, not on our camera. Okay, he can fly off to the distance. Now, the more appropriate way to do this will be target speed. We'll start our moving speed, and on our states we're going to create another one, another header. Let's call this header and call this states, and call this public bool run. So if he is running, then your target speed is going to be your running speed, run speed, and we're going to finally multiply with the target speed. This is pretty raw at this point. Okay, and probably if you are actually falling, well, you cannot fall because we don't have any ground checks. So if we are over here and we get all this, we have our controller, place it in here anyway, it doesn't matter. And if I'm running forward right now, you're going to see that we are actually flying in the air because we don't have any velocity. And something made us, yeah, the angular drag, as you can see, actually made us go like this. Now, let's also raise the angular drag to 999, or actually let's initialize it from the script just to be safe, that nobody forgets. Okay, angular drag, rigid body for drag will be, will start at 4, and then rigid body constraint will start with rigid body constraints dot freeze rotation x. If you set this up from the inspector, you don't need to write them over here, obviously, or, which in this case is going to act as plus. So we have our constraints for the rigid body. We initialize the rigid body in this case. Now we also need to apply our raw input. So move direction. Maybe before we see that, let's do one more thing. let's handle the drag for the rigid body. In here, if we do move, move amount is greater than 0, then that means we are moving. So we can eliminate the drag on our rigid body. Otherwise, leave it at 4. So this will not going to make us slide. And another way to do this will be, another way to write this, move amount greater than 0, then will be 0, otherwise will be 4. Okay, with the ternary operators. So this also handles our drag, and we also have our move amount. Let's see one more thing before we do that. When we are hitting play, this will only show on a controller. It's not going to show on the keyboard because there is no sensitivity. But if I'm slightly pressing the, let's change the values to move speed. Let's go with something bigger. If I'm slightly pressing the, actually there's no sensitivity at all into our input. Okay, so we actually need to work with a move amount because there is no sensitivity on this one. So we have our move direction, we have our target speed, and for the target speed, so that it's not applied all at once, we can simply do target speed multiplied by our move amount. Now, these are our floats. This is a vector 3. If you do this without multiplying these together first, okay, this will basically just do this one first, and then it's going to do this one first. So this is going to force Unity to create a vector multiplication for this, which is performance, and then it's going to create another vector for this one. And we don't want to create any vectors, or well, more than we have to, so we need to combine all the multiplications into one. So we just only create one vector for the same thing. Okay, something extra. Now if we hit play, okay, this will only show on the actual controller. It's not going to show on the keyboard. You can see that I can slowly move like this, or if I want to run completely when I want to run. There is a bit of jagged things that happening, but we're going to also take care of them in the future. Don't worry. Now, into our controller back, let's create something that is going to help us handle with the animations. Let's call this handle movement animations. We also want the actually we're just getting the delta from here, so we don't want this. Deleted. So states, not states, we have the states animator dot set float vertical move amount. Okay, we only want the vertical at this point. It doesn't matter where we are moving or not, or if we are moving left or right, because we are not on the locked on mode. We are on the, we're not on lock on mode. We are just basically moving and looking towards where we are going. Let's put though some offset, or some damping time, and we have our delta saved above. Handle movement animations. Let's go with this one. Let's go with over here and hit play. And now if I'm slowly pressing up, you can see that I'm actually walking. If I go full, I'm actually running. So let's find a proper value to use with this. Maybe 5 it's a little bit too much. Let's go with 3. Yeah, of course we are not looking towards the position. Okay, I think 3 is going to do. So even if I'm slightly like I'm only half of a centimeter, or not even a centimeter, pressing the controller, you can see that I'm not sliding. Well, now I'm sliding because I'm moving towards there. So let's also handle the rotation of our player, which is basically going to be rotating towards our target or our move direction. Let me though see my notes just in case I forgot something. And rotations out here, stats, public float, rotate, speed, let's go with 5. We'll see. In Dark Souls in general you can rotate pretty fast. So fixed stick, handle movement animation, and we have our direction, but I want to edit my direction. So I don't want to mess with my movement direction. I want to keep it as it is. So I'm going to take this. I'm going to be sure that there is no Y, although there's probably not going to be. And then you need to check if you have it the same, or the direction you have to go is at 0. And if it is, then simply assign your transform.forward. Come on. And then we are creating a target rotation. Let's go with target rot, which is going to be quaternion.look rotation target dir. Actually, let's call this TR, and let's call this target rotation, which is going to be our actual spherical interpolation from our own transform rotation to the TR, and then of course transform rotation target rotation, and if you want to multiply by our move direction. Oops, we actually, yeah, we want to do the multiplication before this inside our spherical layer. We have our delta multiplied by our move amount, and actually multiplied not only our move amount and our turn speed, rotation speed, rotate speed. Alright, so this was going to make us rotate towards where we are working to. Hit play. I am that good that I can run on the air. It's not me. It's just that I'm too good. The actual twitching you see might not even be from the controller. It could actually be the camera. So let's see. Yeah, you can see that the player is moving pretty smoothly. So it's the camera that is the problem in here. So let's take the camera and update it in fixed update. So we don't need, on our input handler, we don't actually need this. Take this, put it over here, and if you want to be safe, or you know, whatever, let's comment this out. And you will see that we won't have any problems with twitching. Okay, pretty smooth. Let's also fix the airborne stuff we have. But before we fix the airborne stuff, let's go into our capsule collider. We will see what this is happening over here. We're actually going to use the same method we did on, you know, on the third-person controller, or the third-person controller beta, which it's elevated from the ground, so it's like this. We don't need that much of a radius. let's go with 0.2 or 0.3. Okay, so we're going to be recasting down and seeing where there is ground and putting it over here, over there. Now, on our state manager, we're going to create a new state, public rule on ground, and we can call this, we're going to call a public bool on ground. Let's not bool, definitely not bool. We start as false, return the R, and then we can do an origin, which is going to be our transfer position plus an offset, which is going to be vector3 dot up multiplied by, let's make it public float. Somebody has contacted me. Public float, move speed, let's say distance to ground, I guess. Maybe, yeah, let's go with to ground. And this was going to be, I think 0.5 is enough, to be honest. Right, to ground. And let's close this into this one. And of course the distance, we already have it, to ground. The direction is going to be down, since we're not going to be walking on walls, at least not for this one. And the distance, let's go to ground, but I also want to add a slight offset, so minus more 0.01, so we're recasting a little bit further. Or actually we can go a little bit even further. We can go by maybe 0.3. Let's do a recast hit. Oops. Recast hit, and if physics no material, physics.recast origin direction out hit distance, and we don't have ignore layers, which is a mistake, so let's go make them. No, you are excited as much as I am. Hiding inspector, and let's go. I want to make them public, but I don't want to touch them in the inspector, just so that I can access them from other stuff. And we're going to have ignore layers, because in the future, in the short future, we're actually going to have different colliders for damage collisions and stuff like that. Okay, heat detection, all this stuff. They need to be on their own layer so that we can ignore them. So for ignore layers, I believe should be, yeah, we should make the actual layers. So let's go make them. Edit layers, no tags, layers. The 8 is going to be controller, damage colliders, and should be enough. Yeah, for now at least, it's going to be enough. And this one is going to be 1 bit shift the 8, and if you are bit shifting if you are going to ignore the controller, the colliders for the controller, well, that means you might be in multiplayer, you might be able to sit on top of another player. Just keep that in mind. Yeah, maybe we're all going to ignore, at least for now, the damage collisions. But let's also change the layer of the player to be 8, at least. So ignore colliders over here. Okay, and if you hit something, that means R is true, and it's going to return you this one. And what we can also do is say that transform, or let's create it differently. Target position is going to be our hit.point, and target position.y is going to be plus the to ground. So to ground is basically how far from the ground we're going to be placing our character. Or actually no. Let's go with target position. Transfer. Come on. Transfer the position will be your target position. So here's a little bit of a tricky thing. We need to actually see where we're going to be calling the on ground. We need to be a little bit strategic about it. So I think we're going to just go with on update. So we're going to create public void tick. Let's pass the D, doesn't matter, the delta. Let's update it also, just in case we need it in the future. So on ground will be on ground. Okay, simple. Let's call the update from our input handler. We have our delta and states dot tick, and just pass the delta for now at least. Now on our state manager, well, let's see if this is going to work. If it doesn't work, then we're going to be falling on this cube, and this cube could actually use a little bit of color there. So this doesn't work. The reason why it doesn't work is probably we might be doing a pretty small recast down. So let's see if that's it. We can easily find this. We can just do the draw array, origin, direction, and let's multiply that by the distance. And actually, yeah, now that I think of it, this is wrong. We need to add it to the distance, not remove it. So that works perfectly. Now, when we're on the air, on our state manager, we basically just don't want to apply any velocity. We're just going to be falling down. So if on ground, on ground, and only then apply velocity. If you're not on the ground, yeah, let's write it in here, I guess. So if move amount is greater than 0, add 0, or you're not on the ground, then again add 0, so you're falling pretty fast down. Close this, hit play. Okay, so we're falling down and we can move around. We need to fix a little bit the speeds, as see. So let's try and fix them. Have our controller, move speed. Let's do with, I think it was 5. So run speed can be 8. Well, we don't have run at this point, but yeah, 5 at least is a little bit better. But I think we have the rotation speed might need a little bit adjustment. Yeah, maybe 5 is a little bit too much. Let's go with 3.5. Yeah, I think 3.5 is the deal. Almost. Okay. Yeah, 3.5 is correct. 3.5, so make this not 35, 3.5. Let's make this something like 5.5. Rotate speed, we can actually be more generous. Let's go with 9. Yeah, this is something like you will probably have done a lot of times in Dark Souls. Okay, so it's working. Now, the camera though could use a little bit less speed, to be honest. So let's go with a little bit 7, so it feels like it's chasing the player. So it lets the player a little bit to move towards the direction he's going. Maybe 5. Or maybe 3. Let's go with 3. Although maybe, yeah, I think 3 is a little bit better. Yeah, 3 will do. Let's set this up also a 3. Now, final thing for today. Animator. Override, or well, maybe not override. Let's go with the base layer. Bull. On ground. Alright. Let's see my animations. I think I have a mid-air animation. Yeah. We only have this. So that's going to do. So we're going to call this falling. Like that old gothic song. Although yeah, I don't remember the band. But if you do, you know, write it in the comments. And then we're doing has exit time. On the ground, if it's false, then go over there. Otherwise, go back. On ground is true. And we can do the same, but we don't have to make a transition back over here, since if he goes over there, then he can go back in there as well. Close this. Play. On ground, false, and you can go in here. We still haven't seen anything for the lock-on. This is going to be for the next one. Okay, we're only creating the basic controller. Falling, so that means inside our scripts we need to go on our fixed stick, and we should be updating the animator, to be honest. First thing. So over here I'm going to start with on ground to true. And this is going to be true. True. Let's take all this. Let's see. Maybe it's, yeah, let's go with over here. And we'll see what is going to happen. Again, nitpicking it, it's not really that necessary. You can see that this works exactly fine. Let's try it again. And maybe this needs a little bit of love as well. But yeah, it works. So we have a full-on third-person controller, as you can see. So fast, so simple, in only under an hour. Okay. And of course, it's going to need a little bit more love, which we're also going to see in the next part. So final thing for today, let's add the running, because the run, of course, is going to be fun. So over here, bull, running, or let's just leave it at run, doesn't matter. An arm run. And now we can basically decide if we want to go back to lock-on or normal. Yeah, well, let's just do it like this, doesn't matter. Let's go from both of these. It's certainly going to be when you're running. So that is set. Run to true, and then run will be to false. To false, and if the lock-on is on on, it's going to go back to this one. If it's not, we want to transit back to the normal local motion. So we have this one over here, we have run, false, and lock on. If it's false, go back to this one. Okay, very, very, very simple. Now, through the inputs though, let's go over here, bool, run input, and I think run input is probably we want the left shift, and it's the I think it's the B button on Dark Souls. So let me see the Xbox sim. Edit, project settings, input axis. I think they have it left alt, left control, and fire 3 should be left shift. Let's call this a run input, and fire 3 for the joystick, run input. Okay, exactly the same, and because it's going to be added on a button, on a joystick button, we can actually use the same name. If it wasn't, we will have to be a little bit more creative there. So for right now, I think the B button should be on Windows, it's 1, so we need joystick button 1. Okay, now in here we can say in here on our inputs, run input will be input get button, just button. Controller, usually the controllers don't work with get button up, so that's just an extra tip for you. Sometimes they work, sometimes they don't, so you know, never use them. Easy peasy. Okay, we have a run input, so we can say over here, if you have pressed your run input, and if your actual move amount, or we can just use this one. Yeah, maybe use the move amount. Let's be a little bit safer. It's greater than 0, then that means you want to run. Oops. True. Else, states.run will be false. And maybe over here set it up like states.run should be states dot move amount greater than set greater than 0, and delete this one. Okay, very simple. So on our state manager, on our update, or well, on our fixed update, till here we're only going to be doing this when we are on lock on, so we can have a new state, run public bool lock on, and over here we're going to say if not lock on, and put this one in here. And actually we can use the hand movement animation, I think. Well, let's just leave it at this, and we're going to yeah, because I want to use this when I'm running. Okay, so I'm going to add in here, if I'm running, then lock on will be false. Okay, because basically going to get me out of the lock on mode. And if I'm running, I think movement, hand movement, yeah, let's do it in here. Running, set bool, run, and basically whatever you have on your run. Let's leave it like this. So we are now, you can see we are now actually sprinting also. The keyboard works. Let's see, the controller also works. So we are basically have the full on Dark Souls controller experience. Well, almost. And yeah, I think we have we finished for today at least. We still have a lot of love to do to add to this controller, obviously. So on the next one, we're actually going to start working a little bit with the animations, the attack animations, before we actually do any inventory stuff. But yeah, this will work as a base controller. This is actually pretty nice. Okay, and we have so many stuff, and we also have actual controller like the Xbox controller or whatever. Okay, so you know what to do. Like, subscribe, share it with your friends, share it wherever you can, because it helps, grow the channel, have more views. That means I'll be able to be doing a lot more of this stuff in the future, where it basically prolongs the life of the channel. The other way you can support me is through Patreon, which, depending on the level you are actually pledging, you also get a few more rewards. Okay, that can be watching the videos earlier, getting access to a Google folder where you will find all the scripts from the videos, and of course discount codes through Gumroad, which leads to the other way you can support me, which is of course getting a project or two, including this one from Gumroad. Okay, and everything goes back into making all these nice videos and all this nice stuff. So I'll see you on the next one.